UN 영어뉴스 Megalodon, the super predator that ate its siblings in the womb. Extinct megalodon sharks were the top marine predators of their day and arguably more terrifying than anything Hollywood has dreamed of. The giant shark is back 5 years after The Meg, in which action star Jason Statham battled a huge prehistoric shark. The follow-up, Mega 2, The Trench, is upon us. Once again, Statham will be victimized by a supposedly extinct gigantic shark in increasingly outlandish ways. The trailer has him fending off his huge upper jaw with his foot and leaping over the animal using a water scooter. The trailer also has a scene involving a plate glass window that relies on audiences being too young to have seen Deep Blue Sea. It comes as something of a shock to learn that this clearly, deeply silly film is directed by Ben Wheatley, the acclaimed director of left-field horrors and black comedies like A Field in England and Free Fire. Evidently, he is hoping to make the same jump to the mainstream that Greta Gerwig achieved with Barbie. Regardless of what audiences think of the film, however, the creature it portrays was once very real indeed. Megalodon sharks terrorized the oceans for up to 20 million years before dying out about 3.5 million years ago, too long ago for humanity to encounter them. They were the largest sharks ever to exist and one of the largest marine predators. But just how big they were and how they got that way has only become clear in the last few years. New research is even providing insights into how these creatures may have lived, hunted, and fed. Big teeth megalodon sharks have been known to science since the 1840s thanks to their huge triangular teeth, which are often fossilized. The name Megalodon means big tooth in ancient Greek. The species was originally dubbed Chacharodon Megalodon, placing it in the same genus as the modern great white shark, but nowadays it is classed as Orthodox Megalodon. They weren't kidding about the big teeth. Some specimens are 16.8 cm long. For comparison, great white shark teeth top out around 7.5 cm. Clearly, Megalodon was a big shark, but how big? If we had a complete skeleton, this would be a fairly easy question, but we don't. Sharks are cartilaginous fish, meaning their skeletons are made of soft cartilage instead of hard bone, and cartilage doesn't fossilize well. As a result, the Megalodon fossil record mostly consists of teeth plus a few vertebrae, as those are partially mineralized. We really don't have a great handle on what the shark actually looked like, says Sora Kim, an ecogeochemist at the University of California, Merced, who studies the chemistry of megalodon teeth. This means the true size and shape of Megalodon is uncertain. Instead, paleontologists estimate it. They have done so by measuring the sizes of Megalodon teeth, comparing them to the teeth of other sharks whose body sizes are known, and scaling those bodies up. This is inherently uncertain because large animals aren't simply magnified versions of smaller ones. Hence, there have been disagreements. Many studies have suggested Megalodon could grow to 18 meters or even 20 meters. However, in a 2019 study, paleobiologist Kenshu Shimada at DePaul University in Chicago argued that those estimates were flawed. He argued that the upper front teeth were the best metric, and they yielded a maximum length of 15.3 meters. The Megalodon has long thought to have been an earlier and larger relative of the great white. The following year, a team led by Victor Perez, then at the Florida Museum of Natural History in Gainesville, took a different view. They looked at the width of the teeth rather than their height, as tooth width determines gape size. This indicated that Megalodon really could grow to 20 meters in length. Their analysis is very convincing, says Catalina Pimiento, a marine paleontologist at the University of Churi in Switzerland. Shimada also agrees this upper length is possible. This means Megalodon dwarfed any comparable modern shark. The largest predatory sharks today are great whites, which regularly reach lengths of 4.9 meters. Megalodon could have been 3 or 4 times as long. However, the modern whale shark is on a par with the Megalodon, with one individual reliably reported to be 18.8 meters long. Whale sharks are not predators, though. They are filter feeders that feast on swarms of microscopic plankton. Both are dwarfed by the largest baleen whales. Blue whales are the largest animals alive and can reach 30 meters. Like the whale sharks, they are filter feeders. It is possible that some dinosaur-era marine reptiles grew to similar lengths, but the estimates are based on incomplete skeletal remains, so are therefore highly uncertain. The upshot of these numbers is that Megalodon is not in contention for the title of largest animal. However, it may well be the largest shark ever to have lived, and the largest predator. Superpredator. The teeth alone reveal that Megalodon was a predator, but just what did it eat? To answer this, researchers have turned to chemical analysis of the teeth. One approach is to look at nitrogen. All the nitrogen in an animal's body comes from the protein in its food. The nitrogen comes in two forms or isotopes called nitrogen 40 and nitrogen 50. Crucially, animals' bodies retain more nitrogen 15 than nitrogen 40 from their meals. As a result, animals that are higher up higher up the food chain have a higher proportion of nitrogen 15 in their bodies, including their teeth. In a 2022 study, researchers, including Kim, showed that Megalodon teeth had extremely high levels of nitrogen 15. This suggested it was a top predator that ate the very largest prey, such as predatory whales like modern orcas. It would be a hyper-apex predator, says Kim. However, another 2022 study with Shimada and Kim as co-authors looked instead at zinc isotopes. These suggested Megalodon were more like great white sharks, still a top predator, but not quite as top. Kim adds that the studies also indicate considerable variation. Not all Megalodon ate the same things. The size of the shark's teeth has led to some confusion as to how big this long extinct species could grow to. Some of this uncertainty may be down to the difference between juveniles and adults, says Pimiento. We know from modern species that sharks change their diets as they grow. She says juvenile great white sharks mostly eat fish, while adults go for marine mammals. Young megalodons may have followed a similar transition as they grow. There is evidence of megalodon sometimes targeting small marine mammals like seals. Apex predators are only apex when they are adults, says Pimiento. In fact, young megalodons probably lived quite different lives to their parents. In 2010, Pimiento and her colleagues found megalodon teeth from one region of Panama were usually small, suggesting the sharks were almost all juveniles. They concluded the region was a shallow sea that served as a nursery. Young megalodons could feed there in relative safety, as larger predators would struggle to enter such shallow waters. A decade later, researchers led by Humberto Forón, a paleobiologist at the University of Valencia in Spain, identified more megalodon nurseries. The term nursery, however, can give a misleading image of doting megalodon mothers tending their young. They would just drop them there and then leave, says Pimiento. Modern sharks behave similarly. We've never known of moms to take care of their babies, says Kim. Further clues to megalodon reproduction emerged in a 2020 study by Shimada and his colleagues. They studied a rare set of preserved vertebrae. The megalodon in question was estimated to be 9.2 meters long. The team examined growth bands in the vertebrae, a bit like three rings. These revealed that the animal died at the age of 46 years old, but also showed that the creature had measured around 2 meters long when it was born. This large birth size suggested the fish had incubated inside its mother before being born alive, rather than being laid in an egg, as many fish species do. The team also suggested that the embryo had eaten other eggs while in the womb, helping it to grow so large. While it sounds shocking, such intrauterine cannibalism is common in modern sharks. It means mothers produce relatively few young, but each gets as much nutrition as possible. As well as these nifty methods of parental care, Megalodon also had some truly formidable physical abilities. Hot-blooded ocean hopper. In 2022, Pimiento and her colleagues released a three-dimensional reconstruction of a Megalodon. They scanned a rare, near-complete spinal column and used it to recreate a full skeletal model of the species. We created it based on the great white because that is the one shark that is well studied enough for us to find a scan of the cranium and a scan of the whole body, says Pimiento. They then adjusted the model with data from other sharks because Megalodon is not that closely related to the great white, even if some illustrations show a resemblance. Some modern species, such as mako sharks, are able to keep their internal temperature warmer than their surroundings. With those measurements, we were able to infer many ecological properties, says Pimiento. For instance, they concluded that Megalodon was an adept swimmer that could cover great distances at average cruising speeds of around 1.4 meters per second, faster than any shark alive today. The maximum speed these sharks could reach has been suggested by others to reach up to 10 meters per second, but Pimiento and her colleagues say this is unlikely. The largest Megalodon would have achieved this according to their reconstruction. The drag of the water on their bodies would have limited their top speed, but perhaps younger individuals would have been far more agile. The team were also able to estimate the size of its stomach and its gape. The opening of the jaw was so big that it could fit really big prey, says Pimiento. An adult Megalodon could eat an animal the size of a modern orca in a few bites. Such a meal would then sustain it for a considerable time. Even with one meal, it could have been able to move very long distances, she says. Based on all this, Pimiento and her colleagues described Megalodon as a transoceanic superpredator that could routinely swim from one ocean to another. This active lifestyle was supported by another feature, warm-bloodedness. Animals exist on a spectrum between cold-blooded, meaning their internal temperature is largely determined by their environment, and warm-blooded, meaning they control their internal temperature by generating their own heat. In 2016, Foron and his colleagues presented several lines of evidence for regional endothermy, meaning that Megalodon kept parts of its body warmer than the surrounding water. Then, in June 2023, a team including Shimada and Kim published additional chemical evidence from the minerals in the fossilized teeth that Megalodon was partially warm-blooded. It doesn't look like Megalodon is as warm as a marine mammal, says Kim. It may be that it generated internal heat in its core, but not its extremities. Or it could be that its sheer size helped it retain heat. Either way, it was warm on the inside. This really has huge benefits, says Kim. It enabled it to swim further and faster and to venture into cold waters. How did this extraordinary animal evolve? Evolution and extinction. It turns out that Megalodon was just the most recent in a series of orthodox species, which gradually evolved one into another over tens of millions of years. They were increasing in size through time, says Pimiento, reaching their peak with Megalodon. More broadly, Orthodox is part of a large group of sharks called the Lemniformes. Back in the dinosaur era, the Lemniformes diverged from other sharks. Whereas most sharks were 1 meter, these sharks were mostly 3 meter, says Pimiento. Once they reached this large size, they evolved the ability to regulate their body temperature. This allowed later lemniforms to grow truly huge, but only when their environments were rich enough to sustain them. However, it now seems Megalodon's size and warm-bloodedness may also have been its downfall. The Megalodon became extinct once sea level dropped and there weren't enough prey, says Pimiento. In 2017, she and her colleagues identified a mass extinction in the oceans, which took out Megalodon and a number of other large marine animals. All the animals had a high metabolic demand, she says. Once prey became scarce, Megalodon's warm-blooded lifestyle became too energetically costly. Megalodon is thought to have died out when shallower seas meant it could no longer hunt enough prey. When you are a Megalodon and you are so big, you just need a huge amount of food to keep going, says Kim. This extinction happened millions of years ago. A 2014 study by Pimiento and colleagues put it at 2.6 million years ago, but a 2019 investigation by another group pushed it back to 3.5 million years ago. Shimada says this earlier date is more reliable. While the exact date may need pinning down, what is unambiguous is that Megalodon is no longer around, given that it hunted over huge areas, often targeting big animals like whales. There is no way we could have missed it if it was still around. The Meg films, which suggest that the species has somehow survived, are fanciful, say researchers. It has already been exhausting enough to explain to people that Megalodon is an extinct species and is only represented in the fossil record, says Shimada. He adds that people also sometimes have the mistaken impression that Megalodon existed in the dinosaur era, when in fact it evolved much later, perhaps 23 million years ago. If that date is correct, megalodons existed for a remarkably long time. These titanic sharks are no longer with us, but another one is. Whale sharks reached a similar size, not by becoming apex predators, but by quietly chowing down on plankton. You had these two pathways to gigantism, says Pimiento. This big 20-meter shark is no longer here, but the other almost 20-meter shark, which is the whale shark, is still alive today.